Here are USMLE-style questions on the rate-limiting enzymes of major biochemical pathways, along with their answers and explanations. 1. Glycolysis. A 25-year-old male presents with fatigue and exercise intolerance. He reports that his muscles cramp after moderate activity. A muscle biopsy reveals decreased ATP production under anaerobic conditions. A deficiency of which rate-limiting enzyme is most likely responsible? A. Ruvate kinase. B. Phosphofructokinase 1C, hexokinase. D. Glucose 6-phosphate dehydrogenase. E. Isocitrate dehydrogenase. Answer: B. Phosphofructokinase 1, PFK1. Explanation: PFK1 is the rate-limiting enzyme of glycolysis, converting fructose 6-phosphate to fructose 1,6-bisphosphate. It is activated by AMP and fructose 2,6-bisphosphate and inhibited by ATP and citrate. Deficiency leads to impaired ATP generation and exercise-induced muscle cramps. Act 2. Gluconeogenesis. A 45-year-old woman with type 1 diabetes has prolonged fasting hypoglycemia despite normal hepatic glycogen stores. Which enzyme is most likely deficient in her hepatic glucose production? A. Pyruvate carboxylase. B. Glucose 6-phosphatase. C. Phosphopyruvate carboxykinase. D. Fructose 1,6-bisphosphatase. E. Glycogen phosphorylase. Answer: Fructose 1,6-bisphosphatase. Explanation: Fructose 1,6-bisphosphatase is the rate-limiting enzyme of gluconeogenesis, converting fructose 1,6-bisphosphate to fructose 6-phosphate. It is inhibited by AMP and fructose 2,2,6-bisphosphate. A deficiency results in fasting hypoglycemia due to impaired hepatic glucose output. Nat 3. TCA cycle, Krebs cycle. A 30-year-old man presents with lethargy and weight loss. A metabolic workup shows impaired ATP production and elevated citrate levels. A deficiency of which enzyme is the most likely cause? A. Citrate synthase. B. Isocitrate dehydrogenase. C. Alpha-ketoglutarate dehydrogenase. D. Succinate dehydrogenase. E. Pyruvate dehydrogenase. Answer for citrate dehydrogenase. Explanation: Isocitrate dehydrogenase is the rate-limiting enzyme of the TCA cycle, converting isocitrate to acetoglutarate. It is activated by ADP and inhibited by ATP and NADH. Dysfunction leads to impaired NADH production and ATP generation. Nash 4. Glycogenolysis. A newborn presents with hypoglycemia and hepatomegaly. A liver biopsy shows excessive glycogen accumulation. Which enzyme is most likely deficient? A. Glycogen synthase. B. Glucose 6-phosphatase. C. Glycogen phosphorylase. D. Phosphofructokinase 1. E. Fructokinase. Answer: C. Glycogen phosphorylase. Glycogen phosphorylase is the rate-limiting enzyme of glycogenolysis, breaking UF1,4 glycosidic bonds to release glucose 1-phosphate. It is activated by glucagon and epinephrine. Deficiency leads to glycogen storage disease type V, McArdle disease, muscle, or type 6, HERS disease, liver. Half 5. Glycogenesis. A patient with hyperglycemia is found to have a genetic mutation causing impaired glycogen synthesis in the liver. Which enzyme is most likely deficient? A. Glycogen phosphorylase. B. Glycogen synthase. C. Glucose 6-phosphatase debranching enzyme. E. Pyruvate carboxylase. Answer: B. Glycogen synthase. Explanation: Glycogen synthase is the rate-limiting enzyme of glycogenesis, catalyzing the formation of UF1,4 glycosidic bonds in glycogen. It is activated by insulin glucose 6-phosphate. Deficiency results in reduced glycogen storage and hypoglycemia. 6. Pentose phosphate pathway, HMP shunt. A 28-year-old African-American male develops hemolytic anemia after taking an antimalarial drug. Peripheral smear shows Heinz bodies and bite cells. A deficiency of which enzyme is most likely responsible? A. Glucose 6-phosphatase. B. Pyruvate dehydrogenase. C. Glucose 6-phosphate dehydrogenase. D. Transketolase. E. Fructose 1,6-bisphosphatase. Answer: C. Glucose 6-phosphate dehydrogenase, G6PD. Explanation: G6PD is the rate-limiting enzyme of the pentose phosphate pathway, converting glucose 6-phosphate to 6-phosphogluconolactone, generating NADPH for glutathione reduction. Deficiency leads to hemolysis and oxidative stress conditions, G6PD deficiency. 7. Fatty acid synthesis. A well-nourished patient is found to have increased lipogenesis in the liver. Which enzyme is responsible for the rate-limiting step of this process? A. Acetyl-CoA carboxylase. B. Fatty acid synthase. C. Carnitine palmitoyl transferase. IHAG-CoA reductase. E. Pyruvate dehydrogenase. Answer: Acetyl-CoA carboxylase. Explanation: Acetyl-CoA carboxylase is the rate-limiting enzyme of fatty acid synthesis, converting acetyl-CoA to malonyl-CoA. It is activated by insulin and citrate and inhibited by glucagon and palmitoyl-CoA. 8. Cholesterol synthesis. A 55-year-old man with hyperlipidemia is prescribed a statin. This medication inhibits which rate-limiting enzyme? A. Acetyl-CoA carboxylase, B. HMG-CoA synthase, C. HMG-CoA reductase, D. Farnesyl pyrophosphate synthase, E. Squalene synthase. HMG-CoA reductase. Explanation: HMG-CoA reductase is the rate-limiting enzyme of cholesterol synthesis, converting HMG-CoA to mevalonate. It is inhibited by statins and glucagon while insulin and thyroxine activate it. 9. Urea cycle. A patient with hyperammonemia and confusion is found to have a urea cycle disorder. Deficiency of which rate-limiting enzyme is most likely responsible? A. Carbamoyl phosphate synthetase, B. Ornithine transcarbamylase, C. Argininosuccinate synthetase, D. Argininosuccinate lyase, E. Arginase. Answer: A. Carbamoyl phosphate synthetase. Explanation: Carbamoyl phosphate synthetase 1 is the rate-limiting enzyme of the urea cycle, converting ammonia and bicarbonate to carbamoyl phosphate. It is activated by N-acetylglutamate. Deficiency results in hyperammonemia and neurological dysfunction. These questions cover the key rate-limiting enzymes for all major biochemical pathways tested on the USMLE Step 1. Let me know if you need more practice questions.